Welcome everybody to a showing of The Revenge of the Electric Car. I hope many of you had a chance to check out the Nissan Leafs outside and the Center for Electromechanics fuel cell bus as well. So if you didn't check them out, perhaps after the movie you might go and have a look. There are plenty of Nissan salesmen out there too. They may still even be out at the end of the movie. I'm sure they'd love to show you around. In any case, welcome to everybody from Austin to this showing of Revenge of the Electric Car. Before we start it, I would like to thank our sponsors for the evening, Nissan Leaf and GM Chevy Volt. And with that, I hope you enjoy the film. Thank you very much. My name is Ross Baldick. I am the director of the Center for Electric Vehicles, Transportation Electricity Convergence, which is an NSF industry cooperative research center that is located here at UT, at the University of Texas, and at Texas A&M. I'd also like to sincerely thank our sponsors. As you can see, we've got the logos there, Nissan Leaf and GM Chevy Volt. We really appreciate them sponsoring the afternoon. I'd like to give a round of applause for that. We have a panel this afternoon of some really wonderful people who are going to give us a lot of insights. First of all, starting on my right is my certainly esteemed colleague, Professor John Goodenough, who is the Cockrell Centennial Chair in Engineering in Mechanical Engineering. I'm in the Department of Electrical and Computer Engineering, and we think he's so good that we also adopt him as a professor in our department, but I think he'd call himself a mechanical engineer. He is the father of the lithium-ion battery and has patents on cathodes for lithium-ion secondary batteries, and also developed various technologies for solid oxide fuel cells. So really a very important part of electric vehicles. The next person in the panel is Mark Kapner, who's Director of Engineering at Frontier Associates. Mark recently joined Frontier. Previously, he was at Austin Energy, and while there, he was instrumental in developing and running Austin's Green Choice program, which is a renewable energy marketing program. He's also helped to launch Plug-in Partners, which was Austin Energy's campaign with others to try to get electric vehicles into serious manufacturing. Next is Craig Epling, who is a General Motors Regional Communications Manager. He's worked with GM for 28 years and is currently Public Relations Manager for the South Central region. Fourth, Michael Love, who's Toyota Motor Sales. He is a National Regulatory Affairs and Powertrain Planning Manager for Toyota Motor Sales, and he's come from Torrance, California to Austin today. He's responsible for, among other things, planning powertrains for future Toyota, Lexus, and Scion models. Fifth is Michael Lewis, Senior Engineering Scientist for UT's Center for Electromechanics. He has 15 years of experience in advanced research and technology development at the University of Texas at Austin Center for Electromechanics, UTCEM. He's involved currently in electric and alternative fuel vehicles, including hydrogen and natural gas-powered vehicles. The UTCEM hydrogen bus that I hope many of you saw outside is one such project. And then finally, our sixth panelist is Joe Thompson, who's Principal Engineer at Nissan Technical Center North America. He's been at Nissan for 15 years and has held a variety of roles in systems engineering, and he's now involved in the zero emissions technology that we saw related to the Nissan Leaf. So I've asked the panelists to think about where the future of electric vehicles is going to take us. What are we going to see in the future of electric vehicles? The movie that we just saw has brought us to the brink of an industry, and I'm hoping that certainly my center and I are hoping that electric vehicles really take off. I've got a few questions. I'm going to start off with the first question, but once the discussion gets going, I'd very much like to encourage people from the audience to speak, so I'm going to give opportunity for some questions. We don't have microphones for the audience, so when you ask a question, I will repeat it so that we have it recorded and so the panel can understand it and everybody gets to hear it. So with that, I want to start, and I want to start with something addressed primarily to the Nissan, GM, and Toyota folks, which is there a business case for electric vehicles? Can we get a viable industry? Does it only need garage engineers and innovators and entrepreneurs such as Gadget in the film? Is he going to lead to a viable industry, or indeed does it need Teslas, or do we need car companies with deep pockets, perhaps even deeper pockets than Tesla, to get it going? And along the way, what is the role of carbon and gasoline regulation? So I wonder who of our panelists would like to start on that. Is there a business case for electric vehicles? I guess some of you think so because you're building them. So
on one of them first.
Let's see, is this on? Okay.
Yes, sir.
Well, I think there were more than one question in that. I'll try to take a whack at it. I would suggest that there's no near-term business case, near-term meaning in the next 5 years, for electric vehicles. But I think that that there's hope and investment for all the three companies up here, among others, that in the future there will be a business case so that it makes sense to invest in them. I would say that there's a role for all the three parties that you mentioned, all the way from the garage mechanic through the high-tech startups to the existing car makers, as we try to get toward that future. And I'd let the others chime in on their views.
Well, I think if you look back history-wise, we've perfected a gasoline engine over the past 100 years. Now we're looking to progress. Part of the emphasis for change, I believe, is government regulations. We need 54.5 miles per gallon by 2025 in our fleets. So that gives you some, I guess, reason for change, something to invest in. And I think the electric vehicles, whether it's light electrification or full electrification, will coexist with primarily the gasoline engine here in the U.S. Now think about, where do you charge? Well, gasoline engines, gas stations everywhere. It'll be progressive as we go. There's a lot of things that will take place, whether it's advancements in battery technologies. If you look at range anxiety and so forth, there's a lot of issues that are coming into play right now. And then a lot of people don't understand exactly how the electric vehicle works, what it has to be done. So there's some cost issues. There's a lot of things that come into play in this, but I believe the future can be electric. It's just a matter of how do you get there, what's the investment cost, how do you get the customers involved, and so forth. So it's a challenge for the auto manufacturers right now to invest in it and possibly not make any money going forward for the short term, but yet I believe it is the future.
So I guess being an engineer, I look at it from a different point of view. Basically, if you look at what an EV is, it's a battery, it's an inverter, and it's a motor, and that's how you power the vehicle. So those three components are very costly. So maybe 10 years ago or 15 years ago, if someone said, is there a business case for an $8,000 60-inch television? Probably everybody would have said no. But like anything, if you can achieve scales of mass production, you can reduce your prices, and that's where the business case starts to look better every year. So with Nissan, taking the global launch like we have, we've got factories in the US which will come online in January, in Japan, and also in the UK. So our vision for the future is a mass production vehicle that will be affordable, and that is the way to achieve the business case in our view.
I'd like to. It's on. Yeah. I'd just like to ask a question as to whether you see in your business model that you want to target Europe and the United States, or you want to target Indonesia or India or so on, where you go to smaller cars, but you may not have the infrastructure as far as the availability of electricity. So I'm just curious as to where you people feel your target is. Any of you?
Everyone.
So with the Leaf, you know, we've already launched in Japan and Europe and the U.S. And you know, we're looking in South America and. Speak up. Can better? Okay, sorry. Get a little closer to the microphone. We've already launched in the Europe, U.S. and Japan, and also we're looking in South America. You know, so literally, you know, I don't think any markets are off limits as long as they have a reliable electricity source. But again, it's to achieve the mass scale like we're looking for, it comes with manufacturing, and that's as simple as I can say it.
And I do believe each market has its individual quirks, if you would, as to where you would launch an electric vehicle. If you look at, say, the U.S., yes, you know, we produce them here, but it's if you think about the market, we might sell 14 million vehicles in the United States in this year. How many of those are electrified? Well, it's a small percentage. I think last year 2 to 3% were whether it's hybrid or electric vehicles out of the total. So, but it will grow. If you look at markets like China, it might be a different source of vehicle if you're looking at a large city like Shanghai, and maybe it's a compact, you know, replacing motorcycles or so. In that type of market here in the United States, we're more used to a larger vehicle, one that will go cross country or, you know, fit your needs. But you know, we manufacture vehicles in 36 countries and sell in 120 or so. So there's many different idiosyncrasies of the market needs in each country. So you'll see them in some, I believe, and not in others.
I have it on faith from a reliable source who's been to China that today the Chinese market for electric vehicles is a market for electric bicycles, electric delivery vehicles, what you would call electric scooters. But the magnitude is, and again, I'm taking this on faith that the guy who was there, who's seen 16 million, that's a lot of vehicles. Of course, they probably sell for $1,000 each. And I don't know what the profit margin is. And I don't think they're using lithium-ion batteries. I think they're using the cheapest batteries they can, no doubt lead acid. But there's also BYD, car company mentioned in here. And from what I'm told, I haven't been there, so I'm taking this on faith from people who have, there is a Chinese electric bus industry in operation today.
So are we going to go all electric? Or are we going to see more PHEVs or extended range vehicles? What's the dichotomy there? And clearly the different companies represented today have different views on that. So I want to hear where they think that that technology choice is going to take them.
Well, I would agree that from Toyota's standpoint, you'll see a mix of all of the above, and the only question is what that mix will be. Toyota's philosophy has been that depending on what problem you're trying to solve, whether it's global warming or energy security or energy efficiency, the only way you're really going to do that is if you get the vehicles out there in large volumes, pretty much in line with what colleagues have said. And the big challenge there is making these advanced technology vehicles affordable. And that's the tough part of all of this. It's dead simple to build an electric vehicle. It's not very simple to build them that are affordable and that you can get out there in big volume. So Toyota's tact has been, what has been referred to as a small battery hybrid. We've shown that we can build electric vehicles. We've shown that we can build fuel cells. We've shown that we can build, plug-in hybrids. But our volume has been in small battery hybrids. And in a simplistic way, you can look at it and say, we're putting as much battery in there as we think we can get a significant number of people to pay for. And we've been reasonably successful with that. We'll still admit that the prices of our small battery hybrids are still a lot higher than a significant number of the population are willing to pay. But as we see it, as the price of batteries come down in the future, we'll be able to, people will be willing to pay, I should say, for more batteries. And at some point, you could see the transition to a battery electric vehicle, totally. No hybrids anymore. But it's hard to predict how quickly that will happen. And frankly, we don't see it in the near term because the rate of battery development has been a huge issue and continues to be a huge issue as far as the cost of making, these vehicles and getting them to an affordable price point.
Maybe me being with the University of Texas small research center, I figure maybe I have a little bit different perspective on all this and how I look at it. I understand that you're putting in however many batteries they can afford, but I think in general what is important and what we should keep in mind is the overall trend is more and more electric vehicles, I believe, whether they're plug-in or they're hybrids or they're all electric vehicles. And to meet CAFE standards that we're imposing on ourselves in the future to increase fuel economy, I think in 2025 the goal is somewhere around 55 miles per gallon is the target fuel economy over the entire range of vehicles offered by the auto manufacturers. In order to do that, we are going to have electrification of these vehicles to some degree. The internal combustion engine as it sits right now, as has already been mentioned, we've had several years of research into that technology, and it's going to get small incremental improvements, but to get where we are looking to go to improve fuel economy standards, we are going to have to electrify the cars to some degree. Just to what degree that is still to be determined. It's whatever the market will support. But I guess that's my view.
I do think there's a business case for all different types of electrification, whether it's mild or full, and which one, if you go out and purchase a car, you're weighing cost versus value. A gas at $2.50 versus gas at $4, you look at it a little differently. And also a lot of people are looking at what's my monthly cost for that vehicle. So there's a lot of factors that would weigh into it besides, oh gee, I'm going to get an electric car. But what does it cost your monthly note versus your family income? That is a lot of instances or size vehicle that you might need, size of family. You don't want to leave one kid behind because you don't have a big enough vehicle. Also, there's competing technologies. If you look at compressed natural gas, propane, other fuels, whether it be ethanol, there's a lot of different things that auto manufacturers have to look at to say what is the one that the people want to purchase, what is the one that's infrastructure supports, whether it be ethanol, which is in every gallon of gas we purchase here in Texas, or the E85, which is 85% and only 15% gasoline. If we're getting away from petroleum, there's a lot of factors in there. Electric is one of those, but we don't have, say, such an energy policy in the United States that said this is the way you've got to go. So all the manufacturers are devoting a lot of research and dollars towards each of those and say which one wins out. I think time will tell.
I'm going to add a little bit to this from the perspective of Austin Energy's Plug-in Partners program, which was, as Ross mentioned, a national campaign launched from Austin and actually paid for by Austin Energy and the city of Austin to do a couple of things, one of which was massive market research and advocacy, all directed toward the car companies to present them with evidence that, number one, a lot of people in this country want to be able to plug in their cars. Part of the market research that addresses the question, a plug-in hybrid or an extended range electric vehicle, as it's called, or a pure electric, part of the market research we did was we asked a lot of folks around the country in lots and lots of meetings, which do you prefer? Do you prefer one or the other? And although our market research certainly isn't as good as the market research that the car companies themselves do, because your profits depend on the success of making a product that will sell, we found some answers that are the following. For a single car family, and there are still some single car families, let's face it, in Texas there are more cars and trucks, light-duty trucks, than there are people, including babies and people who can't drive. But for single car families, often a single person, that a person who really wants to buy a car that plugs in, obviously it's going to have to do all the jobs that a car does. You're going to have to be able to drive it well beyond the range of a battery, so clearly a product like the Volt is going to meet the needs of that person. However, for multi-car families, many of them told us, when they understood the characteristics of all electric cars versus extended range electric vehicles and plug-in hybrids, many of these folks told us, I'd be very happy with the car with the limitation of even under 100 miles, because when we want to take a long trip, we use the other car. So the car itself is not a hybrid. The family is a hybrid. They got a car, they got an internal combustion for long trips and for one person, and the person who drives every day to work and back and within the metropolitan area, a car like a Leaf or a Volt or a Ford Focus, all battery electric, or all the others that we hope will be on the market in the next few years. Limitation, 100 miles or less, no problem.
I come back to emphasize this last point. A great deal of the CO2 emission that we get is people commuting back and forth. And to commute, 50 miles on a plug-in is all you need for the lady to take the children to the school and go shopping, or for you to go to the office and come back, and so on. And the question, do you have to have such a comfortable, swishy car that is going to impress all your neighbors in order to get a market for the people who want to be able to just to commute in a way that is responsible vis-a-vis the problems we face with the global warming and so on? And can or do the manufacturers want to target the commuter, as it were, and the person who's doing the small amount here? It seems to me there's plenty of market there if you design something. But I go back to the point that Michael Love made. Cost is a big problem, and clearly at the present moment the lithium-ion batteries have to go a certain distance before they're going to be able to meet the cost requirement that you people need in order to be able to market something for that market.
So that's a nice transition to my next thought, which was, what are the likely developments in batteries, including chemistry, and the implications for size and mass? And perhaps you'd like to start off with that, but the car guys also have some input into it, I think.
Well, what we do in the lab and what you people do, having to actually build a full-size battery, are two somewhat different things. But at the present moment, with the battery strategies that one has, you need a rechargeable battery. And at the present moment, the way you get a rechargeable battery, you have to have something which is rechargeable on the cathode side in particular. You use an insertion compound in which you put lithium, if you're talking about lithium batteries, or a sodium battery if you want to go towards that. You put the lithium in and you pull it out reversibly, but your capacity is limited by the solid solution range of the lithium inside that host. So you also have a problem which hasn't been mentioned. If you have a plug-in, you can spend the whole night recharging your car. But if you're going to have an all-electric vehicle and you want to drive it a little bit, you're going to have a fast charge. And at the present moment, with the anodes that people are using, which has been primarily carbon, but even if they go to silicon, they get a better capacity on the anode, you still are limited in the rate at which you can charge that battery. So we're trying to think of how do we go to a different kind of strategy, because at the present moment one has pushed the present strategy about as far as one can go very easily, and there are going to be some minor improvements, but one really has to develop a new strategy. And one that I'm trying to think about is how can we develop a membrane that will be a lithium separator, lithium electrolyte separator, that will block dendrites that would come from a lithium anode. That'll give you the capacity you need. To get electric to energy density, you're going to have to get both the voltage and the capacity up. The present moment, you start with a discharge battery, and you have an initial charge, and because of the mismatch between the liquid electrolytes, LUMO, and the electrochemical potential of the anode, you have to form a passivation layer on the anode. That consumes the lithium from the cathode, which is what limits the capacity of the battery. So one has to find a way to get around to some of these challenges, and it seems to me that it's going to take a while, but there are so many people now working, trying to develop something that one never knows who's going to be the fellow who's going to get the new breakthrough. But I am looking towards some changes in the electrolytes with putting in a membrane and seeing what one can do.
Rest of the panelists, got any thoughts on where your companies or centers are heading for new batteries?
I guess I could speak to that a little bit. I guess ultimately, I think batteries kind of got they have three challenges ahead of them to get to where we all, would like for them to be, so that we can use our vehicles how we're used to using our vehicles, right? A lot of mention has already been made about cost. Yes, they are expensive, but to get the range we're looking for, we need increased energy storage density within the batteries. Right now, the current technologies are lithium is where it is. We're probably maxing out that technology, and as Dr. Goodenough mentions, we need further advancements there. And then the other side is, just as Goodenough said, beyond energy storage density, so you can get the range, you need power density within that same battery package, so that you can accept a high rate of charge. So that's where other technology developments are needed. But the difficult part here, though, is usually those two things do not go hand in hand. Most technologies out there, you either get one or the other. You either get an energy dense device or a power dense device. I could speak a little bit about the bus that's outside. I hope all of you get a chance to go see it. That's a project we've been working hard on. Some of our partners are here in the room today. The Center for Transportation and the Environment, NREL's in the room as well. And the bus manufacturer, Proterra, is in the room here as well. And they have a slightly different lithium chemistry in their batteries to where they are actually able to take relatively high charges, up to 6C rates of charge. And their platform, that bus, the one that's sitting out here, is actually uses an onboard fuel cell range extender to recharge the lithium batteries as the bus drives around town all day. It's currently in service with Capital Metro, driving on the UT shuttle route, so be on the lookout for it. But their bus, they also have a few of them going into service in San Antonio early next year, maybe in January or February timeframe. But it uses the same battery chemistry, but rather than carrying around the fuel cell range extender, it stops at a bus stop once every loop, so every maybe 10, 15, 20 miles, and fully recharges those batteries within a matter of minutes. We're talking roughly 50 kilowatt hours worth of batteries, which is roughly the same size that you see on the Leaf and plug-in vehicles. But their system is able to recharge those batteries in an order of minutes, 5 to 10 minutes. So that technology is there for some lithium chemistry batteries. But once again, you know, nothing's for free. They're not as power dense as traditional lithium-ion batteries, and of course, the price is still relatively high as well.
One thing I didn't mention is also part of the cost is the life of the battery. And you're going to want to have a 10-year life for a battery if you really want to break into the market. And that means you can do that right now at a high cost with your titanium anode and your the LiFePO4 cathode, and you're within the window of the electrolyte, and then the cycle life is 50,000 cycles or whatever, and that's fine, but you only get 2 volts at that point, and you still have the cost issue. But you can go at that point 10C, 20C rate and still get that life and cycle. So the problem is, how do you get a hold of the energy density you want, as well as the power density associated with the fast charge, as well as the fast discharge? And so that's where the new strategies have to come in.
How is Nissan dealing with battery lifetime?
How are we dealing with it?
In terms of replacement of batteries, battery packs, individual batteries, I believe you have some strategy to deal with being able to replace individual cells as opposed to complete batteries. Is that part of the solution to the sorts of issues that Dr. Goodenough has brought up?
The actual warranty details I don't know off the top of my head, but the way the pack is designed, with diagnostics, we were able to locate any cell or module if it had a defect and could replace it as a one-off item. That's possible. We haven't had to do that, but that is possible by the design of the system.
Mm-hmm.
So that makes it very serviceable, so to say.
Yeah, the battery packs in vehicles, you know, individual cells, say the Volt has 288 individual cells. What we do with the Volt, you know, extreme heat or cold are, you know, bad for batteries. So we actually use Dextron coolant, same as in your radiator, to keep the battery at a more constant temperature. Now, the cells are serviceable. We're also working with a company called ABB on what do you do after the life of the battery? You know, you're finished with your vehicle. What do you do with the battery? How do you recycle it or such? Well, we're working on saying at the end of the life cycle of your vehicle, you probably have 70% or so battery life capability still there. Well, say if you took a couple of batteries, stacked them together, you might have, say, emergency power for your home, or maybe hospitals or so. And you run a trickle charge through that, you're able to then have an extended capability of that battery rather than putting them in a landfill or recycling it as such. So we're working on that type of solution that's down the road, but you got to start working on all that now. So there is some capabilities there for battery and future for them as well.
Sure, if there's a relevant question to this line, please tell me. So I think the question is it the cost of the batteries that drives the overall drivetrain cost to be high? What if we had a magic wand, what would we focus on that would make it much more affordable? Is that a reasonable paraphrase?
Yeah, I'm going to take a stab at that because I checked this out before I came over from Nissan Leaf and from some other sources, including there's a company that spun off out of your research and your colleagues' research, Dr. Goodenough. Acticel here came out of UT, and it's going strong, was just acquired by Contour, another lithium-ion battery company. So the information that I have here is that today, the replacement cost of the 24 kilowatt-hour battery in the Nissan Leaf today, they're saying would be $750 per kilowatt hour. So multiply that times 24, and that is presumably the current today's replacement cost for that battery pack in that car. You do the math. Some folks, several folks are claiming that it's actually not that expensive. There really are companies offering battery packs equivalent to the battery in the Nissan Leaf, the current lithium-ion technology with the characteristics needed for an electric vehicle. It's actually closer to $500 per kilowatt hour. Well, okay, 24 kilowatt hour pack, that's $12,000 for the pack alone. I think that kind of approaches the answer. Yes. Yes.
I was going to come back
No,
to...
it's no secret that the cost of the lithium-ion packs are the main item. And as Michael said, from Toyota, their strategy was to try to optimize the size of their battery for getting electric range, but minimize the cost. So it's the same issue every automaker faces, is how do you minimize the cost impact of the vehicle for the battery. And it goes back to what I said earlier. That's why our manufacturing strategy is important, and to have our own manufacturing and to achieve volume so that we can control those prices somewhat.
And there's probably economy of scale in that too. In other words, I usually, it sounds like it probably has a lot to do with it.
I think we'd have to know what the commodity cost of the materials are compared to the development cost, right? And I don't know that anybody's going to share that with us today, unless you know the
It's
answer.
not just the cost of the materials that are in the chemistry of the battery itself, but if you want to build in the safety, and you want to build in the fact that you have to put in a lot of cells, and you've got to have a battery management that has to go with having so many cells in a stack. Those costs, as well as your quality control on the chemistry of each cell, those things add to the cost, and one has to find a way to be able to get where you can do that. I wanted to ask a question back here of the Chevy Volt people who claim, well, they're going to keep the temperature of the battery fine. I just wondered how you sell Volts in Winnipeg in the wintertime.
Well, the coolant that goes around the battery, is kept at a more constant temperature, so that it does assist in doing that. Whether you're here in Texas with 100-degree weather or you're up in Winnipeg where it's freezing, that is a strategy for extending the life of the battery, and we're able to do that on the Volt.
Michael, did you have a quick comment? Then I want to move on to a different topic.
Well, just to the point that the battery is the single biggest challenge, but there are still issues in terms of the power electronics and the electric motors. There's continual development. I know Toyota spent a lot of time in its various generation of the Prius figuring out how to take cost out of the power electronics, how to take cost out of the battery, the electric motors, and make those more efficient. But the single biggest cost hurdle is the battery. And I would point out that lithium-ion batteries are in massive production already with all the power tools and other applications. So they've already come way down the cost curve. And so the prospect of future huge savings or cost reductions in lithium-ion is a little bit daunting. I think I would agree with Dr. Goodenough, if I understood him correctly, that lithium-ion may not be the be-all, end-all solution battery. I know Toyota's made statements that it's looking beyond lithium, and it thinks it needs to go there to really have the breakthrough necessary to make the battery electric vehicle. And when I earlier stated, I didn't think there was a business case for electric vehicles in the next 5 years, I was speaking battery electric vehicles, so just to clear that up. But again, we think there's, as Dr. Goodenough said, there's a lot of smart people working on trying to find that battery breakthrough. That's I I think there's a lot of money in it for whoever does do that. And I think that includes the three manufacturers at this table are all doing their own battery research. And we see that as one of the, the critical factors at being able to market a successful electric vehicle. And we don't want to leave that in somebody else's hands. So we're all doing it ourselves. We're all arch rival competitors, and I think it will happen. It's just a matter of when.
Super. I have one more question for the panel, and then I want to open it up to people with their hands up and the questions. And so the last question kind of segues off the last comment. Is it impossible for a new car company, an outsider car company, to achieve enough economies of scale and knowledge to really become viable? And I mean, that obviously speaks to whether or not Tesla is reasonable. And why I think that's so important is that the strength of the U.S. economy and advanced economies is innovation. And innovation in the large car companies have innovation centers, but it seems to me that Elon Musk, for example, probably started out in a garage when he invented PayPal, right? He didn't come out of a large corporation. And it seems to me that a lot of the really wonderful things that we've got, like the iPhone in front of me, both had a flavor of garage entrepreneurship, at least in the beginning, and large corporations. So how does large car companies and tiny innovation fit together? Is that possible? And what does that say for innovation in the car industry?
Sure. You may not want to hear from me, being that I'm not one of the auto manufacturers, but maybe I can get this jump started. But as I see it, as the video shows, it takes a lot of money and investment to get to where you can compete with the large auto manufacturers. And in typical passenger vehicles, I would see that's very challenging for startups and entrepreneurs to get into that market and make a name for themselves. But I do agree with you, Dr. Baldick, that those groups are necessary for innovation. That's where the bright ideas come from and the research come from. I think it's hard sometimes for maybe a large auto manufacturer or company to invest the millions of dollars it takes to get a company like Tesla or get that innovation out there. You heard he put millions and millions of dollars into that technology and into that car, which helped to get all the electric vehicles in this market rolling. But at the same time, I think maybe there is a niche for slightly alternative modes of transportation, whether they're small scooters, three-wheel vehicles, maybe small neighborhood electric vehicles. I think kind of the garage entrepreneur may be able to find a market there. And then also there's other vehicles, heavier duty vehicles, but transit buses or whatnot, delivery trucks, where a smaller garage outfit company might be able to make a mark as well.
I just add to that one obvious comment, and that is you find out where the Achilles heel is that's keeping the whole thing from moving forward. You've already identified the battery and the new strategies with the battery and so on. So there's plenty of room for somebody who's not trying to make the entire car, but is just trying to fix that part of the thing which will enable the electric car. Mm-hmm. And so there's plenty of room for entrepreneurs in trying to develop new components for batteries.
Yeah, and just to follow on there are companies which have decided they're going to focus only on drivetrains, electric drivetrains. They work on power electronics. They work on innovations to the motor. They buy the batteries. Over the years, it's interesting, there have been, I would venture to say, dozens of startup all-electric car companies in the United States alone. And of course, there's the rest of the world. I mentioned China before with the 16 million electric delivery bicycles and scooters and such. But in the United States, there have been several dozen companies that have made efforts. It turns out the only one we really hear about are Tesla from the movie. And then, of course, in addition to that, the gadget guy doing it literally in a garage. There are, in Austin alone, I know of 3 startup companies that are just doing conversions. You bring them a car, or at least the chassis of a car. They, if it's the right kind, they said, okay, we take out the drivetrain, We take out the gasoline tank, of course, and the air pollution controls and such, and they put in the motor, the power electronics, the battery pack, and give you back an all-electric car. So there's a lot of innovation going on. It's all under the radar screen except for Tesla.
I do think America's built on innovation, inventors, and so forth, and that's what made us great. The challenge, say from a consumer standpoint, on an electric vehicle or anything that's new, you want to be able to touch it, feel it, test it, see it, and know where to go get it repaired. So that's where a larger manufacturer would come into play of having some advantages, because they'll have them there at a dealership, they'll go for test drives, bring it back for servicing if needed. You have all those capabilities that I think as far as a consumer, I know I'm a techie type of guy, but I want to go look at it before I buy it. And it's I think an automobile is not a mail order type product that you're just going to order and somebody delivers it to you and you say, okay, well, if I got questions, who do I talk to? I think it's still something you'd rather someone local that you can talk to, and I think that's a challenge for a startup type company.
I think that's a pretty good point there. That one thing the startups, beyond a warranty for you, or going and getting your car, like your current vehicle retrofitted to an electric vehicle, one key aspect you're missing out there are probably safety and regulation issues that are put in place that the Toyotas, GM, Nissan have to abide by when they sell you that vehicle. Going to your local garage shop, getting your vehicle converted isn't necessarily going to meet all those safety standards. I looked at the guy's little Porsche that he had converted there and all those batteries right in the front hood, and I wonder what happens to that car in a collision. That's obviously something that if your large auto manufacturer will have to put that vehicle through testing, and is a reason why it's going to be hard to compete with those guys as well. To undergo that type of testing and development is not a trivial task by any means.
Well, beyond what's been mentioned, I would suggest that one of the biggest challenges for a new entrant into the auto market trying to build an electric vehicle are the state mandates that all the large manufacturers must build zero-emission vehicles, because what it does is it forces a lot of people into a nascent market, and that makes it tough for a new entrant to try to compete. To be honest, I think it goes together with some of the earlier comments that you find a niche where there is nobody serving it, and that gives you some room to get your company up and running, and you don't have to worry about going to battle with the huge auto companies. I mean, GM made the comment back with their EV1. One of the worst things that happened is with the ZEV mandate in California, it forced everybody else into competition with them. And I think those who believe you can mandate a market ought to think long and hard about that. So it's just another factor.
Okay, I would like to start some questions. So this gentleman here, I think, was one of the first.
Dr. Goodenough made a comment
So you're right. When you add more energy density to the lithium cell, obviously the cell has more chance to be reactive. So, but that same situation exists, and I think some of the research that's going on at Argonne Labs, for example, they have coatings even today that they've developed that you can apply, which reduce the heating profile of batteries that have been damaged due to internal shorts, but it takes away maybe 10 to 15% capacity, so no one's too eager to adopt them yet. And in general, the safety mechanism of the vehicle design with high-strength steel to protect the battery system is the way that most manufacturers are achieving that now. But you're right, energy density is everything, and if you can get it keeping the same weight, the same packaging space, then that's what everybody would strive to, as long as it was affordable.
There are two sides to the energy density. One is the voltage and one is the capacity. If your energy density is going up because you're increasing the voltage, then you've got a problem of safety that you raise, and it depends upon how you're going to design your electrolyte and how you're going to design your material, that you don't get short circuits or something in the battery, which is going to cause a problem. So if you're talking about batteries for, say, storage of electrical energy from wind and solar, you use a different strategy. You might be able to get a flow-through battery and so on. You'll extend the capacity, but not necessarily the voltage beyond what the electrolyte will take. But it's why I talked about trying to make membranes and so on, that we hope you can maximize the voltage, but there's going to be a voltage limit. There'll be a voltage. You'll never get a battery with more than with a cell with more than a 4-volt or 4.5 volt voltage on the individual cell that will be safe. So you're going to have to go for capacity.
Well, okay, on energy density, do the math. A gallon of gasoline weighs less than 8 pounds. I don't know exactly what the specific, but it's less than 125,000 BTUs in 1 gallon of gasoline. And if you need to, if you're not familiar with the conversion of BTUs to kilowatt hours, it's at 100% conversion, 3,413. So do the math. You don't have to do the math. Obviously, gasoline has an enormous amount of energy density compared to even the best battery we can ever dream of in the future. So if you're concerned about energy density and safety, we are all driving extremely dangerous vehicles every day.
Enough said.
I think someone at the back had a, yes, sir.
Okay, I'm trying to shift gears, so I do a supply chain going forward.
So what's the supply chain issue with electric power?
Okay, I'm going to take a first stab at that, even though I just spoke. If part of the supply chain, obviously, is the fuel supply, and the fuel supply is the electric power system. And this is really good news, because the electric power system has been waiting for years for something just like the electric vehicle. We've been waiting for years for a very, very big nighttime, middle of the night electric load to come to us and to enable the electric power system to increase the output of extremely expensive power plants that we've been building over the course of the last century to meet the peak demand. On the hottest, in the South, on the hottest day of, the hottest afternoon of August. So we've built in Texas 70,000 megawatts of generating capacity. In the middle of the night, on even the hottest day, the peak day, middle of the night, it drops to 35,000. We've got all this excess capacity that we've paid many billions of dollars for, that you've all paid for, of course, and you're paying for through your electric rates. And finally, we have a new electric load called the electric vehicle. That is really good news for the electric power industry. And it's good news for everybody, because the more we utilize this tremendously underutilized asset of power plants that are sitting at part load or sometimes being turned off altogether, many of them just sit at part load, operating throughout the night, waiting for the next morning to ramp up, and you've got all this economic investment, this asset, billions of dollars sitting there that could be used to provide the fuel for the cars that your companies are going to make. So
Mark,
from the electric companies, this is great news.
But Mark, how do you square that with what I would perceive as a huge move to have fast charging, daytime charging, which from my perspective as someone and also involved in an electric system, is absolute anathema of what you're describing.
Absolutely.
And it will exacerbate our electricity problems.
Yep.
And it's all about reproducing the experience of going to the gas station, something which I hate doing, and everybody hates doing, when, in my take, exactly the sort of thing you're describing, nighttime charging, would be a much more preferable story. So I would like to hear from the vehicle manufacturers about how we square that and why we on the electricity side are so crazy in our position.
Well, a little bit going back to the original question too is think locally here in Austin. You've got the Pecan Street project, which is involved with UT here, and then also the Miller Street neighborhood, the old airport, for those who don't know the exact neighborhood. We're using that as a little test area. We've got right at 60 Chevrolet Volts in one neighborhood right now. Think about also, we introduced an app for your phone that you can be able to say when the vehicle charges. So if I just need it at 7 o'clock tomorrow morning, it'll start charging whenever you plug it in. It might wait to charge, so it's off peak. You can then say start it at 2 a.m. And then also in some of these homes, I was visiting one a couple weeks ago, you know, the gentleman was showing me on his TV, he can tell by each outlet how much energy the vehicle is using, how much energy his refrigerator is using, and so forth. And Austin Energy can do the same as well. So it is something right here in Austin that probably you're not going to reach that multitude of electric vehicles in one neighborhood. You know, and that's just Chevrolet Volts. There's others in there, but that's our largest concentration that we know of in one particular neighborhood. So it's an advancement and a little bit of a test bed right here in Austin.
Well, I'll answer your question with what the utility companies tell us when we meet with them. Basically, they have no concern about being able to charge the vehicles due to the generation capacity that they have today. The Electric Power Research Institute, I remember maybe a year ago, they did a lot of studies, and their interest was in the distribution system, basically at the transformer. And you know, the way transformers operate today is they see their peak loads during the day hours, and then at nighttime they cool off, and then the cooling mechanism what helps them have the life of 20 or 25 years. So if you had a distribution circuit with an old transformer and you had 3 or 4 vehicles on it and they all charge at the same time, that could present some problems. But some utilities are now adopting rate structures where you know you can get a different price if you charge after 9 o'clock or do things like that too. So, but by and large, what we hear from the utilities is they really have no concerns even with today's technology as it exists.
Yeah, and just to quantify the answer that I started getting to, several studies by NREL and by Pacific Northwest Lab on how many electric vehicles could come onto the market, assuming, and Ross, you pointed out, assuming that there's charging during this valley of the electric load profile and not during the peak. How many cars could come onto the market without needing a single additional unit of power plant? And the answer was somewhere between 75% and 85% of the entire United States car and light-duty fleet could instantaneously, of course very hypothetical, convert to all electric vehicles and charge. Everyone could charge up during this valley of the load profile without the need to add any new generating capacity. Of course, that's highly theoretical, I would say.
Another question? Yes. So can we improve the efficiency of the car? I guess this has several dimensions: rolling friction, energy storage, internal combustion engine. Anyone want to take a?
Well, I think that's a good point because the IC engine vehicle, the conventional vehicle, it's been in production for so long, still has continuous improvement on board. I think you're seeing that with the new vehicles rolled out today. And that's actually something to think about when you think about the potential benefits of electrifying the vehicle. Its competition is not standing still. But there is, I think, some practical limits, and the electrification that's been talked about from light to heavy hybrids and all the different variations are also ways that you can improve the efficiency of the vehicle. And I think you'll see a continuum, as a colleague from GM here said before. You're not going to have some instantaneous switch to all one technology. You'll have a variety of technologies competing in the marketplace, and it will be the marketplace that will eventually decide which one works best, or the people will buy what works best for their particular need. But I don't think you'll see, an all or none type situation.
Are there any final thoughts from the panel before we wrap up?
I'll just make one comment. Well, that was a question. They're more important for people to answer a question.
Just one comment, I guess, on efficiency. If since we're at a university and you guys want to know what everybody's studying, obviously the onboard chargers are a big item to have as an efficient design, because you're taking AC, you're moving it to DC to charge the battery. And then when you take the DC out of the battery and you go back to AC to drive your motor, you're using an inverter. So your inverters have to be efficient. Your drive inverters. So quite honestly, you can have low rolling resistance tires and do those kind of things. But the real studies and the push for even better optimization is on your inverters and your chargers. So that's kind of where the industry is.
You do have more questions, but I'll just add one. Yeah, okay. Since it hasn't come up yet, we have an awful lot of wind energy in Texas now. Of course, as you all know, we are the leading state by far. And this past year was 8.5% of all of our electricity in Texas came from wind. And that's probably going to double in 5 years when the additional lines are built. There's an interesting synergy between wind energy and electric vehicles. The winds in the central part of Texas, the north and the west, tend to be at their strongest in the middle of the night. And of course, what else is going to happen in the middle of the night? When we're asleep, our cars will be plugged in. So we will actually be able to say we can drive our cars largely on West Texas wind rather than Middle Eastern oil.
Well, with that, I would like to thank our sponsors, GM Chevy Volt and Nissan Leaf, and I'd particularly like to thank our panelists. There's a reception after, and any questions that... I know we didn't have time to get through all of the questions, but I'm sure some of our panelists will be only too willing to be questioned further while we enjoy